Good morning. We'll be starting here in about a minute and a half. And a nice warm day. I shall go with that. That's got a nice tropical feel to it. Here we go. Okay, we'll give folks about 30 seconds to catch up and get completely logged in. Okay. Can tell it's a hot day because people are online. That's good. Okay. Welcome to our webinar on Guiderail, one of our foundational webinars. My name is David Orr. I'm the director here at the Local Roads program, and welcome very much. Hopefully you're having a cool day. You can stay in a cool spot, and we'll play that by ear. This is the last of our webinars for June, but we'll have a lot more coming up through the rest of the summer. We're going to be going all the way down to snow and ice in September. Good thing to think about, right? Snow and ice, September? Sounds good? Okay. So if you haven't been on one of our webinars before, down on the bottom left is your audio settings. If you have any issues, you can check there. You can always send us a Q&A question. Open up that pod for Q&A. You also want to open up the chat pod. That's where we'll put links in. We'll repeat those links because we know you don't see them unless you actually have it open. So go ahead and open that chat pod up. That's where we'll put our handout, which you'll have for today, and any message that we've got for you, including a direct link to the polls, so you don't have to type it all in. I may ask you to raise your hand now and then during the course of the hour together. And with that, we'll go ahead and get ourselves started. Now, this is worth one professional development hour in New York State, but it is only the person registered unless you let us know in advance. So it's only the person registered. And it counts as a course, though if you haven't realized it yet, in New York State, they've dropped that requirement that you have to have a certain number of their courses. So it's a PDH. Just may have to, go from there and we'll make that work. Okay. Now, if you're from another state, obviously you might have to check with your LTAP center, but we'll see where you are here in just a sec. So let's do a little welcome, and we'll start with some polls using Poll Everywhere. So let's first off find out, who do you work for? Okay, we've already got some people who've been voting, so that was the one I had active. So you get to vote early, vote often, I guess. But let's see, we've got state or federal, we've got county, a few city folks. Just a few town folks, a contractor, and we've got a bunch of you with the hot weather thinking about working for the weekend. If you cannot access the polls, we know this happens, please feel free to put your answer into the Q&A. That does still help me make sure we're getting interaction, but more importantly, who's there and what questions you've got. Okay. Wow, I've got a high percentage of state today. I'm going to see if I've got my set up right for the highway design manual. Okay, so what is your job? What do you do? Are you an administrator, highway superintendent, an engineer? I suspect we'll see a lot of engineers today. Are you actually in the field crew? Though that's a pretty important group for Guiderail. Planner, board member. You do whatever the boss tells me to do. None of the above. If you put none of the above, please do me a favor and throw it into the Q&A. And again, if you can't access it, I see a lot of people putting in things like commissioner/engineer. So I can just add that to the pile. And as I expected, about 2/3 of you are engineers, some planners, and supervisors. Okay. Okay, that helps me. And then now we see where you're from. Click on the map, and just you can actually click right on the map. Tell me where you're from. Again, if you can't access the poll, you could put where in the state you're from. Oh, we have somebody from Ontario. Oh, either that or up there watching it. Okay, we got a New Jersey person. Maybe that's our click we have. Okay. Okay. Nassau County, an engineer from Missouri. Wow. Cool. Okay, so we're going to talk about rail. We call it Guiderail for my friend from New Jersey, from Missouri. You call it guardrail, but it's the same stuff. So we'll figure it out. Now, earlier in the spring, we did a whole series of webinars on the state's roadway departure safety action plan. And one of the proven countermeasures was barriers. And again, barriers can include more than just rail. In fact, I'll actually touch on some things beyond rail a little bit. And where do they work? Well, they work to minimize severity for head-ons, rollovers, fixed objects, curves, tangents. When you need it, rail is really valuable. So, you know, let's just get you to raise your hand and ask. Raise your hand. Do you think you need rail here? So let's just again, we're going to make you work a little bit. So, do you need rail? I'm hoping most of you raise your hand. This would be a spot over in the Gunks, not too far from New Paltz. It would be really hard to make this safe as we'd like it to be without some kind of rail system. You can't really do any the other steps that we'll talk about here in a little bit. So yeah, this is a spot where you definitely need rail. So now I'm going to lower everybody's hands, so don't keep clicking. Lower your hands, and let's just ask that same question. Do you need rail? What do you think? How many of you think you need rail here? Okay, not as many of you think you need rail here. And we'll talk about whether or not what you could do if you didn't have rail here. The big thing I want you to take home more than anything else, if you decide to put up rail, please put it up so that it will do the job. Okay? This particular rail has some issues which we'll talk about. So again, make sure you do the rail right. Now, what we're going to talk about, we're going to start with roadside hazards. What are we trying to protect? Okay, again, if you can't access the polls, that's fine. Just put your answers in the Q&A. I can add it in. It's not the end of the world. We're going to talk about roadside hazards. What's out there on the roadside we have to protect by doing certain things, including rail. We're then going to talk about the treatment options themselves. And then what is the correct rail? Selecting the rail is pretty important, including the intersections and transitions and things like that. And then we're going to end with a series of short case studies, putting it all together to see how you're doing. And also maybe pick up a couple of final items as we go. Okay, so let's start with roadside hazards. So what kind of roadside hazards are we dealing with? Well, let's just ask you, what kind of roadside hazards? So type into the poll some typical roadside hazards, things you're worried about. Trees. Oh, very good. Trees. I like that one. Again, you can put it into the Q&A if you can't access it, and trees is up there. Rivers, ditches, curbs, utility poles. Yep. Abutments, fixed objects, houses, rocks. Yep. Buildings. Well, I like that. Banks. It could be a bank as a building, or it could be a bank as the side of a road. That's a lovely thing about English. Yeah. Okay. And over in the Q&A, I've got piers, I've got rocks, I've got bollards. Again, there's lots of things we can think about putting out there, and there's a few others that I've got on my list. So let's see how we got here. So I like the fact that the first thing y'all came up with was trees. Trees are really a very important thing we have to protect, but can we really put rail up to protect all trees? Probably not. Probably not. But let's make sure that when we do put rail up, we put it up in such a way that it will actually do the job and protect us from hitting the trees. And obviously, if we've got a tree like the one on the right, pretty clear evidence that tree's been hit just a few times. So maybe we need to think about doing something above and beyond just putting up some tape, I guess, and a couple of orange hobby horses. Okay. Now, one thing I didn't mention, and again, this is not a rail issue, but it is something that we have to think about for roadsides. Rail doesn't do us any good if we've got a poor edge drop off. So just keep that in mind as we're thinking about our treatment options. Long before we worry about the rail, we need to make sure someone can actually get to the rail. So look at your edge drop offs, include that. You want to think about your cuts and your walls. You know, a wall that's nice and smooth on the inside or a cut section might not be as dangerous as a fill section. And is that wall enough, or do we need to do something a little bit more? That's a balancing act, and there's no perfect answer here. We're not going to give you all the details you need, but in an hour, we can at least think about the kinds of concerns that we might need rail or might not. Now, obviously, slopes, that was on your Wordle that we created. Slopes is a major issue, a big fill section. Obviously, someone goes off this slope, that could be an issue. But the challenge is, if it's a really low volume road, is it worth putting up the rail? And we'll talk about that a little bit. But slopes is an issue. In fact, it's probably the place we put most rail up. Someone put in their rivers and streams. Obviously, especially if someone can get behind the rail system, if they drove into a river or a stream, especially if it's deep, that could be a safety issue or a pond. So these are things to think about. Now, nobody put the next item on my list in the Wordle, and yet it's out there, but it would be awfully hard to put rail up to protect it, and that is mailboxes. Okay? We need to make sure mailboxes don't, in of themselves, create a safety hazard. So think about that. And again, we can do things before we put rail up to make it a little bit safer. And the term appurtenance, a new word for you if you don't have that one in your vocabulary. Appurtenances, that includes your signs, your poles, your guide rail. These are all things that we have to deal with. If they get struck, they can create a safety issue if they're not installed properly. And so by themselves, they can become a fixed object that we want to be careful about. So this is a single post sign. And as you can see, it didn't do what it's supposed to do. It really should be crashworthy or breakaway. It should not actually create a safety issue for the person inside the vehicle. There's a slip one designed for the interstate. There's an old style that's still used to this day. There's a close-up of it that fails in a very particular way. But, you know, simple breakaway hardware, the particular one in this case is literally $1 piece of hardware, just a proper bolt system. Again, there are things we can do. Heck, we can make breakaway utility poles. We're not going to get into that. If you're interested, there's details in the handout, and we'll mention that a little bit later on. So, signs is one I want to just touch briefly on. Again, the main thing with signs is we have to make sure we put in the proper breakaway hardware. And this particular post combination has some serious problems. Luckily, it's on a low speed situation, so it's probably going to be okay. But if this were a high-speed roadway, you know, the state speed limit of 55 miles an hour, we'd not be happy when we hit this. It would definitely cause some issues. If you're looking for the handouts, they're in the chat pod, but we can also email it to you if need be. But again, rule of thumb, anything that's out there that could be considered a fixed object, if it's above 4 inches in height, it can snag a vehicle. So again, you want to keep it short. Good rule of thumb, 4 inches. And that's 4 inches, not just of the ground, but of the where the vehicle might snag on. So if it's rough terrain, you might need to check that as well. Smooth, not high, won't snag a vehicle. Good rule of thumb. Now, I said I'd talk about this a little bit. Poles, we can't do much about all utility poles, but if we have a pole in a particularly difficult location, you can't move the pole and they really have a problem, they do make breakaway poles. You know, we don't want a breakaway traffic light pole because obviously if it falls, that can create other safety issues. But for utilities, they do make such poles. If you're interested, there's a lot of information in the state's highway design manual section on Guiderail, which is chapter 10, and that's listed in the handout if you need a link to that. But the thing I want you to think about is the fact that Guiderail in of itself, and again, some people call it guardrail, but Guiderail is what we use here in New York. Guiderail in of itself is a fixed object. And if it's not done properly, it can actually make crashes worse than if there had been no rail there in the first place. So I want to make sure we understand that before we leave after the hour together. Now, when it comes to fixed object crashes, the first thing y'all listed were trees. And the reason trees get listed first is because 48% of all the fatalities that occur when you hit a fixed object is because somebody hit a tree or a big shrub. So yes, we know trees are an issue. We can't get rid of all the trees, but we can think about where trees are and how we manage them a little bit. Okay. And by the way, if you're wondering, trees in urban areas can be just as deadly. Low speed still has a lot of tree fatalities. So trees are the big issue. Signs and poles, Traffic signs, utility poles, yeah, that's a pretty high percentage. So we at least want to do what we can to make those break away a little bit safer. Other fixed objects that are man-made that we put in there, um, that's going to be a high percentage. This could include us putting up a stone wall. This could be things that are like the buildings that you mentioned in your stuff, can be a fixed object crash. Barriers in of themselves, that includes guide rail, jersey barrier, sand barrels, all of those things are a fixed object. So again, we want to put them in correctly. And then finally, other fixed, and I don't want to label that natural because it's still got some man-made stuff to it, but a rock ledge, uh, something that is not installed by us, still can be a fixed object that we got to worry about. Now, um, somebody has in there, what about pedestrians? This particular chart deals with fatals from single vehicles running off the roadway. We certainly can talk about pedestrians. There's some issues with them in urban areas. Rail has a hard time in that particular case, but something we can deal with. Um, so in terms of the clear zone and a basic recovery width, a clear zone, if you remember, is essentially the distance from the edge of the traveled way until the first fixed object. Okay, in the state's chapter 10 on Guiderail, the Highway Design Manual, that is also listed as a basic recovery width. If you've got a wide roadway, like on the interstate or a major road, you actually want some width where if a vehicle pulls off, it would be safe for them to drive and not hit something. Okay, we know that clear zone requirement is going to be very difficult for a lot of people. Okay, so just something to keep in mind. I mean, the requirements that are in the state's highway design manual range from 8 feet on a fairly flat slope all the way up to 30 feet on a high-speed roadway. And I know you're all thinking the same thing right now. You're all going, hey, it's too small. That's okay. If you really want to look at these distances, go and look at Table 10-1 in the Highway Design Manual, which is listed in the handout. And I see a question about breakaway testing requirements. I'll talk about that here in just a minute. And we'll leave that question active, though, so I don't forget it when we get to that particular section. Okay. Thanks, Jody and Amanda. So what is the clear zone on existing low volume roads? Well, there's a standards from AASHTO called the Low Volume or Little Green Book. Okay, it's designed for low volume roads. If you read that carefully, essentially, if you've got an existing road and it's low volume, and low volume we could argue about, but it's about 2,000 vehicles at the upper limit. 400 might be a more realistic number. But if it's an existing road, you just maintain the existing clear zone width. And there's an asterisk there, though, and that means you do need to look for problematic issues. Maybe it's something that's never had a crash, but still could lead to an issue that's very severe if it did have a crash. A series of row of trees may or may not be a problem in of themselves, but we'll talk about that in a little bit. The key is you need to look at your problem locations, and you would improve anything during construction. So if you had a tree or two that was a problem, or especially on the outside of a curve, that's where you'd be spending your money and your effort. Okay. Now, are there any issues here? Well, if you've seen this picture before, I've shown this in a few other of our slide decks. It looks like it's not too bad to the left, but think about if you drove to the left and you didn't see these stumps, okay? By far, one of the biggest things that once you decide you're going to remove something, remove it. Make it flush. Again, that 4-inch rule is pretty important. In this case, those stumps may actually be more dangerous because they're really hard to see than a tree would be. So someone might actually think they're going to a safe spot when they're not, okay? So before we put up rail, we really need to think about the treatment options that we've got. What we really don't want to be seeing is fixed objects that look nice, but could be deadly, okay? So the first thing we want to do is think about the order. Long before we put up rail, we're going to be doing other things. We're going to remove the problem. We're going to make it traversable, as safe as possible. We're going to relocate it completely out of the way and get it outside the clear zone we would like. Reduce the impact severity, and some people use the term crash worthy. Some people you'll see use the term breakaway. There's some overlap in all of these things, but the idea is you're still going to hit something, but hopefully when you hit it, it's not so severe. And we can argue, by the way, about what is traversable, what is crash-worthy, what is breakaway. I just want you to keep that in mind that long before we put up rail, we need to make sure things are as safe as possible. Rail is actually one of the last things we look at, shielding. Now, the standards all say for higher volume roads, especially, the last thing we want to do is delineate. I will tell you right now, personally, as a short term, you should always think about delineating things. And there's some evidence for those low volume roads, in this case, at the 400 vehicles per day level, that delineation may actually be less risky than putting up rail just because the challenge of putting rail up, okay? So keep that in mind as we do things. Now, what I mean by removing, well, that means get rid of the hazard completely. Now, some people will say that I've just made this traversable by filling in this ditch and putting in a series of catch basins so you can drive over it. You get a nice wide clear zone. True, but we've removed the hazard from the standpoint of the driver. If you can remove it, that's obviously our first choice, and we actually can do that in some cases. And when we end our session today, we'll talk about a couple of those. You can make things traversable. Now, in a perfect world, traversal means going over the top, and there's still something there. Maybe that catch basin, the last one, was actually traversable. There are things out there to make end of culvert pipes, especially those parallel to the roadway, a lot less dangerous. Doesn't mean there's not going to be property damage, but if you drive down the road, you could drive over these rebar grates or these special ends that go on the end of culvert pipes without doing anything other than property damage if they're installed properly. The ones I like, by the way, you can grab on them in a storm event and pull them out of the way, but we can talk about that. But again, remember, whatever you put up might create damage, and that 4-inch rule still comes into play. So let's look at a picture of a fatality. I'm not showing the actual fatality, I'm showing you the location. Okay? This was a fairly small head wall for a culvert. Okay? The van that hit this rolled off the roadway, hit that, didn't see it. They saw a delineator, but they didn't realize that it wasn't traversable, and it caused the vehicle to roll over, suddenly slow down, and you can see there was a fatality, series of fatalities there. So again, that 4-inch rule is a pretty important one. And where you can cut things down and let people drive over it, you're almost always going to be better off. And our ditches in of themselves can be an issue. If the ditch is fairly sharp, when a vehicle hits it, it can lose control. In this case, it rolled. Okay, and again, led to a very severe crash. So try to, as best you can, think about if someone were to drive off, what would happen to them when they drive off the roadway. Can't do 100%, but do the best you can to make it traversable. Now, if you can do so, especially with small fixed objects like utility poles, relocate them if you can. In this particular case, that series of utility poles is right in the bottom of the ditch. Almost one of the worst places to be. Obviously, I think all of us would agree, we really should be having that pole. Let me pick a color I think will work. Let's see, I think the white will work. We really should be having these utility poles up here, up on the top of the bank, okay? So that if a vehicle does go in the ditch, which, yeah, it's probably a little deep, but at least if they go in that ditch, they don't go down the ditch and wind up driving right into a utility pole. Now, even if you've got a flat ditch, think about this. How many of you, raise your hand if you think that utility pole needs to be moved? Raise your hand. Please raise your hand. Please raise your hand. Everybody should raise your hand. That utility pole is in one of the worst possible locations. It really needs to be back up on the top of the back slope. Okay. I actually ran the math on this particular one. If I was to move that utility pole right here, just off the edge of the pavement, it would actually have about the same chances of getting hit as where it is now. Because yes, it's closer, so it's more likely to be struck by an errant vehicle, but I don't have to worry so much about someone who goes all the way in the ditch and stays in the ditch. That's actually a fairly common crash type. They go parallel the road to the bottom of the ditch. So, I mean, obviously what we really want to do is put that thing out here. And I hope, by the way, that that pole, that post, is breakaway, not too thick. Gets bigger than 4x4, you need to be thinking about drilling holes in it, things like that. So what do I mean by crash-worthy or breakaway? Well, crash-worthy or breakaway, reduce impact severity, different terms for it. Here's an example of a gang mailbox. Watch what happens. Rather than it going into the vehicle like we saw earlier, it's designed to actually snag on the hood and pull out of the way. Okay? Again, it's going to do some property damage. We know that. But it's not going to go into the vehicle. So that's what we mean by crash-worthy or breakaway. That includes mailboxes. And yes, I see the states putting them up. I think it's a good idea if you've got a high-speed roadway. And what's high speed? Well, anything above 30 miles an hour is probably a place where you need to be thinking about, worrying about people hitting something in the mailboxes. And it's not the speed limit I worry about, it's what people are actually driving. So think about breakaway. That's your breakaway hardware for your signs. That's your breakaway possibly for utility poles. Anything that has to be in the right of way or has to be in the clear zone because of the need we have for traffic, think about making it crash worthy or breakaway when somebody hits it. So now, and finally, we're 25 minutes in, we're finally talking about shielding. Okay. Now we're going to focus on rail, but when they say shield, that could include rail, but it could include a small thing like a concrete barriers. But please do me a favor. If you're going to shield, shield. In this case, somebody wanted to protect this tree because they want to remove it for some reason. So they moved the road and then they put up barrier. As you can see, it might have made it more dangerous because now if a vehicle does hit that because the road swerves a little bit, they're actually going to go right into the tree. It's going to launch them. Um, Shielding can work, but you really want to shield it properly. In this case, they wanted to save the tree. They actually used sand barrels. Okay, and crash barrels do work, and they're actually described in the highway design manual. They have their place. You'll see them on the interstate, and there are places where I think you could actually use them where you just can't get the rail in, but you really need to protect something. So it's something to think about. Now, again, as I said, the last thing we think about is delineation. And yeah, maybe we need to have this delineator's bolt reattached because obviously it fell upside down. So we put a bolt back in there and we get our delineator going the right way. But the idea is we delineate. Okay? So delineation is pretty important. In fact, in this particular case, this is a very low volume roadway, less than 30 vehicles a day, even in the summer. I would say, and sometimes it's almost better to just think about delineating something until you can get in there and do something more permanent. And do you want rail there? It's really low volume. It may not be worth the extra cost and the risk. On the other hand, that is a pretty big drop off. Before you put rail up in your community, make sure you have a plan. Why did you do this road before? Why did you do that road? Okay. So I want you to list the steps for dealing with roadside hazards, and I'm going to throw you a poll, so let's see how you do. So what are the steps for dealing with roadside hazards? Let's see how y'all do. Remove, very good. Okay, so people put remove. What else we got? Delineate, again, that'd be the last step most of the time, unless it's really low volume. Remove the fixed objects. Relocate, I see somebody in the Q&A. Got in there too, good. We're looking to see if we get all 7. So we've always seen remove and relocate, put in other ones. Yeah, make sure, check your clear zone. What have you got? Delineate. Make traversable, I see over in the Q&A, that's good. Reduce the severity, make it crash-worthy and breakaway, that's good. Okay. We are looking for one more. That's a pretty important one. In fact, it's the reason we're here today. Shield. You got it. Okay, shield. Okay. So essentially, think of it this way. You want to remove the problem, make it traversable, relocate the problem, make it crash-worthy if you can't do any of that, and then we start talking about shielding. And you always look at delineation. And on a low volume road, that may actually be the right thing to end with if you can't do anything else. Now, so let's now talk about choosing the correct guide rail. Now, what is guide rail? Well, guide rail has different types that are out there. We care a lot about the deflection distance behind it, the point of need, where do you actually have to start the actual rail segment? That makes a big difference. I'll touch briefly on something called run out length. On a local road, you're not going to see a lot of that, but you might see it on the interstate or protecting a river or stream, but something to think about. And then we'll definitely want to talk about end sections because you don't have a good end section, the rail doesn't do the job. Now, in the Q&A, somebody asked for information about breakaway systems, okay? And what's going on with breakaway systems. Today, we used to do breakaway and hardware testing that includes signs and rail with something called NCHRP, the National Cooperative Highway Research Program, Report 350. But that got replaced almost a decade ago, now 2016, with the Manual for Assessing Safety Hardware. Okay, there is a newer version, but I just want you to realize it's been around for a while. All hardware gets tested using this system. It accounts for the vehicle types and sizes, and then the Federal Highway Administration actually puts out letters to say, hey, these have met the particular standards, and then states will adopt those standards. So inside of the HDM, it lists the hardware that the state uses here in New York State. New York State has actually spent some money to test box beam, which we'll talk about, and cable rail using the new MASH system so that the current standards here in New York meet those requirements, okay? But again, those need to be approved materials. And then in terms of guidance, you'll look for that material information in MASH, okay? Now, how does guide rail work? That's, I think, one of the misnomers that people have. And guide rail is a good term from that standpoint. How does it actually work? Well, it's a big rubber band. So watch what happens with this cable rail, okay? Now I'm going to play that twice because it's important enough. I want you to see it. So let me make sure it plays twice here. Watch. It's a big rubber band. It deflects the vehicle. It lets it go as far as it possibly can and brings it back to the roadway in a semi-controlled manner. And a good test, property damage, yes, but the person walks away essentially without serious injury. And if there's a driver in there, these are driverless tests, they'd probably actually be able to stay in their lane. Okay. Though why they left in the first place, that's a good question. Okay. So something to think about. Now, is this rail doing the job? Well, no, it's not once it comes up. Hello, thank you. And the reason is I can't build up the rubber band effect. I've got little short segments of rail that are doing something, but they're not really doing the job guide rail or guardrail does. They're not providing that rubber band effect. They're not going to do much good except in a low speed situation. They're not much different than just a barrier fence for a pedestrian or a bicyclist. So really we need to include full lengths of rail, and the ends make a big difference, as we'll talk about. So what common types do we have to deal with? Well, obviously, we've got cable rail, we've got weak post W-beam, box beam, heavy post, blocked out W-beam, concrete half sections are the most common. Now, there's tri-beam, there's lots of connectors, there's special things you can do with all of these. But again, we're just going to touch on these and talk about how we choose one over the other. Now, cable, again, as I said, the state spends some money on cable systems. Okay, they've done some testing on it. Cable is light, has a huge deflection distance. It does have some issues. The anchors are critical. One on the right, I'm not sure about that anchoring system. Going around a corner can be tough. You can even see on this long, shallow corner that we've got the rail starting to bend over. This is a picture taken. Hello, Jim. I see Jim Markles in here. He took this picture. You can see the rail starting to tip over. And that's a challenge. You have to maintain it. And cable rail, you do have to maintain the turnbuckles, keep the pressure, keep the tension in those cables for them to do the job properly. So a lot of agencies, especially if they don't have a large staff, might prefer to look at using a weak post W beam. It's essentially a fairly small post with just a W rail in front of it. Okay. It's very popular, can be made with the Cortan brown, all that fun stuff if you want. But again, It's got to have the transition. It's got to be able to build up that length, but W post is very common. Box beam, a state likes box beam here in New York. DOT, as I say, had some of that tested using MASH. You'll see box beam all over, and it's used on a lot of bridge rail, especially multi-box beam for the bridge, and then it goes down to a single box as the approach system comes into place. You can have heavy post W beam, okay? So you can see this particular one has a nice in section, which we'll talk about in a little bit, but there's the W rail in front of a blockout, and if you look closely, you can see what the blockout looks like. It's usually plastic or wood, and the reason for that is to help make sure somebody doesn't snag on that heavy post as they hit it. Because obviously snagging on that post, that's a fixed object. You never want to see the heavy 6-inch size I-beam post with the rail right on it. You really do need that blockout, okay? Now, some of the newer systems have fancy names, like there's one called MGS, again, but you can actually see this is some testing done with Nash. Yeah, I see the note. I'll come back to the note in the QA in a second. But there's a nice test on a 2-to-1 slope. Again, I'll show that one again. That went too fast. Clicked on. Oh, you're not playing for me today. I'll just do it the old-fashioned way. But notice this is right on a slope. Okay, does pretty good. Okay. And does a good job if the posts are embedded properly versus here. You got to have soil support for your post or they're not going to do the job. And what's going to happen is going to deflect more than you want. And it could actually get a situation where some of the posts don't deflect, some do more than you want. It can actually snag a vehicle. So that can lead to a very dangerous situation. Now, someone noticed in here that, in fact, our friend Jim, that the Core 10 rail has been disapproved because it didn't oxidize right. And he's correct. Again, you want to look at the current list. The key here is if you want to use something that aesthetic, think about what you're really trying to do. Make sure it's from the approved list. If you're not sure, ask. Doesn't hurt to ask, okay? And does New York State typically use an 8 or a 12-inch blockout? Most of the ones I've seen are actually only 6, but the point is make sure you get approved blockout. In fact, we'll go like here. You can see. Yeah, I can go back up. There you can see that's an 8-incher. But the one I've got in my office, most of them are 6. But again, go look at the standards. The key is to keep that rail from getting snagged. Concrete half sections, well, you don't want zero deflection. Concrete half section can do the job. But how do you transition to zero from no deflection? That in sections on concrete can be a challenge for it. So what type of rail should you use? Here's the thing. I'm a big believer to use the lightest possible rail that will do the job. Okay? The lightest do the job. Okay? Because there's no point in putting up something heavier, it costs more, and actually starts to actually create some deflection problems. Okay? So something to be thinking about. Now, somebody asked quickly, does the nice car safer barrier used on highways anywhere in the country, is it too costly? I'm not aware of any location that's got it, but that doesn't mean it's not there. It's a big country. We're talking about general types and local guiderail policies that have been developed. I don't know of any local ones that have been developed. That's not a bad idea to have a policy dealing with residents because residents want rail. And railing, again, is a fixed object in of itself. But the people like to jump to it immediately. So I don't know of any particular ones, but if you've got one, send it away. We'd love to post it on our website. What drives what rail system we're going to use? Well, it goes back to that deflection distance again. The lighter the rail, the more the deflection distance. This is one of my favorite photographs I've ever taken. Okay, this is a W rail, and there's a tree behind it. Let's go look at the deflection distance for the different types of barrier. This is in your handout, but notice, cable, I can only get down to about 7 feet, even if I put really tight post spacing on a high-speed roadway. Yeah, there's some deflection reductions if you get lower speeds, but let's just assume high speed, 7 feet. W, I can only get down to 5 feet. Okay, light rail. Box beam, maybe 4. If I need 2 feet or less, I got to go with the heavy post W rail with the block out. And yes, there's a way to get it down to 0 with some special, extra hardware. But for general W rail, we're talking 2 feet. And if I want 0, I've either got to do something really special. I'm going to have to go with the concrete half section. So let me just ask, looking at the table, I'll start the poll, okay? And then I'm going to ask you, what's the minimum deflection distance for weak rail, W rail weak post? And I'll be nice to you. I'll show you the chart. Just look on the chart. What's the smallest number for weak rail, W rail weak post? It's 5 feet. Very good. Yeah, it's 5 feet. There was a time when they would actually get these down to 3 feet, but it didn't really change the deflection distance. So yeah, it's 5 feet. Okay. So you can decrease the post spacing all you want, but it's not going to really help. So in this particular case, the reason I like this photograph is because shortly after I took it, the tree was removed. And then shortly after that, a vehicle hit that. If it had not been removed, that tree, the rail would have actually directed the vehicle into the tree. Now, someone did notice in the Q&A that you want to make sure the rails are lapped in the proper direction. So you don't want to have them going downstream, lapped properly, overlapped, going downstream. But make sure the bolts are proper. Replace and put new bolts if they're ever struck. Don't reuse the bolts. Check the hole sizes and things like that. Now, the other thing we got to worry about is something called the point of need. And again, you're going, it's too small. I know it's too small, but it's in the handout, and we just want you to understand this concept. The idea is you need to start the rail to actually protect the object. The actual point where the rail does its job is protecting the object. So now let's just imagine that I've got this rail system. I know I need to extend it because I don't like that end fist. They never like those. So how far back do I need to go if I want to protect this tree right here? Okay. Now, yeah, there's a whole bunch of trees, but let's just assume I want to do that. Well, to do that, you can calculate it out. The distance you'd need to start the rail is r times 1 over the tangent of 15, because that assumes the vehicle's coming in at an angle of about 15 degrees. You can do the math. 1 over tan 15 is just under 4, 3.73 if you care, but use 4. It's conservative. It's an easy way to remember it. So if this is off the roadway, 8 feet, I'd need to come down 32 feet. Okay, so let's do one more. Okay, so let's look at the rail type. And that rail, again, we know that rail is not going to do the job. Okay, the one tree's probably got to be removed, this one. But let's say we want to leave that one tree, and it's 7 feet, the flexion distance that we need. How far back does that need to be? Well, it's again, you can do the calculations. You just do W rail, assume it's a tight spacing, and your point of need then is 4 times that distance, and 28 times, to get 4 times 7. If you do it exactly, it's 26.2. Oh my. Yeah, 28 feet. So in other words, I would need to get this rail to protect that tree, I really need to actually bring it down here 28 feet and then put an end section on it, okay, for it to really do the job properly. So keep that in mind, where the rail starts. And that's one of the reasons that a lot of short rail systems just don't do that much. Now, I just want to briefly touch on something called run-out length. This is really what you're trying to protect, someone who could get in behind the rail system and they drive along, and you don't want them running into a stream or over a steep bank or something like that. Again, mostly seen on the interstate. You're not going to really do it that often on something like this. More likely, you're going to be thinking about that deflection distance and that point of need. But imagine, we just know the rail's not long enough. Because how long does those run-out links need to be? Well, they can get pretty long. At 55 miles an hour, we're talking 360 feet. So it'd be a long distance if someone can get in behind the rail. So it has to have a good clear zone, a flat section. Again, I just wanted to bring that up. The run-out length is something to think about. Most local roads are not going to be able to put it in, but you might want to think about it on the interstate or in a section where you've got a large flat area, okay? And really, you're trying to protect somebody from getting into water or going over a bank or something that could be dangerous. Now, you know, with a W rail, your run-out length here would be 165 feet for low-speed roadway. Still a pretty long distance. So now let's talk about end sections a little bit. Again, we could spend a whole hour and a half, well, we could probably spend a whole day talking about our end sections, but I just want you to be aware of them. This is how the rail works, because like you see in the picture on the left, there's no end section. It's not going to build up that strength. So you can do several things with end sections. You're trying to avoid this. Here's a case whereby someone got and hit the rail at just the wrong spot. The end section didn't do its job, and it actually tore through the vehicle. So there's things you can do. You could anchor in a back slope. Okay, so now someone who hit that rail, they would have a back slope to protect them. At least sweep it outside the clear zone if at all possible. That's nice. Okay. You could do a turn down in, though, again, turn down ins, low speed, downstream, yeah, would work, but just be aware that they have their challenges. Okay. I'm going to stop the chintzy music here. I don't know if you can hear it, but I can. So, and I'm going to skip forward a little bit. Watch what happens when someone hits one of those turn down ends. That's the one we don't like them anymore. Okay. So those turn down ends that just go down quick, yeah, they can lead to all kind of problems. What you really want to be thinking about is using some kind of crash-worthy terminal. And again, I'm not going to argue for any one of these over another. Make sure you understand there's two types. There's tangent ones, there's flared ones. They absorb energy in one form or another, or they're designed to break away if someone hits them beyond a certain point. So a lot of these systems are designed so if you hit them on the ends, down like, let me get my pen working here. I think I need, we'll try blue. If you hit them out in this zone out here, they're actually supposed to fail, or in this case, these actually shear out. But if you hit them on the end, they just peel away. It's pretty cool. Okay. They essentially work that if you hit anywhere beyond that anchor section, they have full strength. So again, we'll watch this and see how the video shows. And you can see just beyond, and it gets full tension. So you've got full tension past the third point. It's pretty cool if they're installed correctly. But if they're not, it's not going to do you much good. If you don't properly attach these end sections, they don't work. So you've got to make sure they're anchored properly, whatever you choose. And you really do want to have good end sections. There's a lot of good choices out there, and we recommend them to give you the strength you need. And of course, if you're approaching a bridge, they're absolutely vital to transition from a light system to a heavier system to, in most cases for bridges, zero deflection. So as you're doing it, think about that transition. In this case, good example of what not to do, because the rail actually helped direct the vehicle right into the concrete. And that would have been a fatality if it had not been a test case. In fact, here's an example of rail prior to getting hit that led to a fatality, because it's not a good rail system, and all it really did was help direct the vehicle right into the end of a zero deflection rail system on the side of the bridge. So you really need to gradually increase the stiffness from whatever the light system you've got. There's plenty of choices out there. Go find one, and as you're looking at your systems, think about upgrading and replacing. Obviously, none of these are really going to do the job. There's no transition in the one on the far left and the bridge on the right. And that cable system, that old style heavy post, the cable might work, but if somebody hits that post, you might as well just put a concrete bollard and they're just going to hit that. So plan on updating and replacing your systems. And don't just look at the rail system. Here's one that Jeff Scott, our technical assistant engineer, took. It's a great picture. The rail doesn't look too bad if we look at the roadway. But when you get out, you can actually see that it's lost all that support down here. Oh, come on, pen. There you go. It's lost all the support. And so therefore, it's not really going to do that much good for a vehicle because you're not going to get that soil support that we talked about. Okay. And some of the rail systems, here's another one that Jeff found. I think this cable system is probably a little antiquated, and it's been a while since it's been looked at, since the cable is actually in the tree, yeah, we could do better than that. Okay? So now, let's put this all together. I want you to now think, we're going to look at a series of pictures that I've collected. And by the way, if you've got a good, bad example, please send it my way. What I really prefer are ones where you fix the problems, got the before and the after, just so you know. But let's put this all together. What we're going to do is I'm going to show you a series of photographs, problems. I know you can't do everything. That's okay. But I want you to think about, is this a site where we should be thinking about removing any hazards, make them traversable, relocate the hazard, make it crash-worthy, shield it, i.e. put up rail, delineate it in some way, or just do nothing? And then over in the Q&A, you can also throw in, are there other things to think about when you look at this particular site? Okay, you ready? Here we go. So, first one. What would you do here? And just so you know, the traffic, we already talked about, the traffic on this road is less than 50 vehicles a day. What would you do here? Again, this is all going to be in the Q&A. We're not doing polls on this one. Some people would put up rails. Some people would do nothing. I want to see at least delineation. Okay? I'm a big fan of delineation and again, on very low volume roads, and this is a very low volume road, the risk reward may actually be such that delineation is all you need to do. The biggest thing before you put rail up here, if this is a town road or a county road or even a low volume state road, make sure you have a plan for the entire area. The whole town, if it's a town, at least part of the county, if it's a county, because if you don't have a plan, you put rail up here and something happens somewhere else, you're going to go to court and going to have to defend that. So make sure you have a plan in place. And obviously you can't remove this hazard because that's, 25 feet, 30 feet down to the edge of one of the Finger Lakes. So that wouldn't be an answer. So in this particular case, I would be a big fan of at least delineating it and only looking at shielding after I put in a plan. Okay, and I'm gonna change my color. Okay, let's try this one. And again, somebody asked about, do I know of a local plan? As I had said earlier, no, I don't know of anybody who has a plan for what to say to the public for rail. I do know of plenty of agencies who develop local road safety plans and or guide rail plans so they know which roads they need to upgrade to improve their systems. These are local road safety plans would be the approach that I would take there. Okay. So what would you do? So what do we got? We've got delineate, we've got shield, make traversable, remove and replace. Okay. Again, what would happen if somebody drove off into this ditch? The ditch isn't bad. They'd probably be okay. I mean, they probably wouldn't roll their vehicle. But if they've got any speed at all and they hit that, it's going to be a really, really bad day. So again, this is a case where you could write a policy and not allow these kind of fixed objects in what is now your right of way or your clear zone. Okay. So in this case, obviously, I like the fact some of you said delineate short term. That's not a bad idea. Longer term, this is a case whereby one of those rebars, extend this out and put one of those rebar systems would be in there so that it becomes, again, some people would argue that that makes it traversable. Some people would argue that makes it crash worthy. We can discuss that point if you really care. That's a nuance in my mind. Obviously, we can't remove the driveway. We can't relocate the driveway very easily. And shielding driveways is really tough. It really is very difficult. So yeah, making it traversable. And again, maybe we want to put in, at least short term, some kind of delineation system. Might help the drivers too. Okay. Okay. So what are we going to do here? Going to remove it. You're going to replace it, make it traversable, make it crash worthy. Again, transition rail, that's good. That's what I was looking for. This is one of those cases whereby we obviously can't remove it. We can't really make it traversable. We're going to have bridge rail. Okay. So we can't really do any of these things. So we're going to be doing some form of shielding, But what I want to make sure of is the shielding does the job, doesn't make the problem worse. So you need to make sure that that shield has got a good transition to it. Okay? That's critical, a transition plan. So go out and look at your bridges, your large culverts that have fixed systems on them, and think about the approaches that you're going to have for that. And you need to transition and improve those. So let me show you an example of a small culvert and ask you what you would do here. I can think of 4 things you could do here that would be pretty cool. And there would actually 4 different answers that would be possibly be correct. Again, if you have an overall plan. Obviously, short-term delineate. Yep. Maybe you got to shield that. I mean, maybe you look at it, you realize I got to shield it. It means I got to have a transition plan. So shielding could be one of my choices. Delineation could be one of my choices. I might be able to extend the culvert out into the beyond where it is now, and then I could remove this head wall. Let me change the color so you can actually see it. I could remove that head wall, and then I would not necessarily even have I could actually, in this case, I'm actually going to be, I'm not removing it completely, but I'm making it traversable. Okay. So I'm actually could make this traversable is a possibility. Okay. And then finally, yeah, I probably want to trim that out. And again, some people would argue that makes it crash worthy. Uh, yeah, there's lots of things that we could do here. Okay. Could you put a crash barrel in? Yes, you could put a crash barrel in some cases. Um, always comes down to the economics of it and can you maintain the system? Okay. Got a couple more. We're good timing wise. What would you do here? And by the way, let me show you the culvert you're protecting. I think I've stumped him. Yeah, I think this is actually a perfect place to think about removing the problem. That's a small culvert pipe. If you wanted to put one of those transition, those covers over the end of it, that's a possibility. But I actually would first think about removing this. Maybe either crash worthy or traversable, one of those great end things. Can't really relocate the culvert, so they got to keep that. In this case, to put the shielding up, you're going to have to extend it quite a bit. Okay. And short term, yeah, you're probably going to do nothing. In fact, that's what's been done here. But those end fist, if this was high speed, luckily it's not, I'd be real nervous. I don't like those end fist. Those fist ends, when someone hits them, are really dangerous. Okay. So keep that in mind. Okay. Okay. And then what about this one? You've seen this picture before? Yeah, remove that tree. You're still going to have shielding here. That's the thing to keep in mind. You're still going to have shielding here, but remove that tree. And again, make sure it's down flush. You don't want to have that in a situation where it's above 4 inches in height because it could still get hit. Okay. So make sure it's flush down here. Okay. So that doesn't snag something if someone does hit it. Because remember, that's going to have a 5 foot, could have a 5 foot deflection. You're probably going to still think about shielding this because this is a sharp corner on a steep grade. There's a bank over there you can't really see. So you might have to do a combination of things to make things safer. Okay? Okay, what are you going to do here? Yeah, you got to make that crash worthy. You're not going to get rid of mailboxes, but don't let someone put, essentially, if you look carefully, those are angle irons. Someone hits that, it's going to be a really bad day for the plow, the driver, whoever hits it. Okay? They make mailboxes. There's standards for that. Um, don't let people put that. There's a place where you can have a policy for mailbox standards, and the post office does have standards that exist. Okay. Replace with a 4x4 post or the metal ones. Yeah. Okay. Find a big nail. I like it. Somebody's having a little fun. One last one. Okay. One last one. Yeah, you might be able to do nothing. That utility pole is tilting, but it might be far enough back you'd be okay. So doing nothing might be a possibility. After, one thing I would do, I'm going to put an asterisk here. And my asterisk, please see the ditch. Um, but that's my drainage hat. I got to do a little drainage something. Always have to include safety and drainage and everything. But think about that. Sometimes we can do nothing, and that's okay. In fact, we're doing it right now. With that, we're right on time where I want to be, but anybody have any questions? You can throw a question in. We can do what we can to help you out. No, nope, no questions. Okay, well, with that, we are just about where we need to be. In fact, there's the top of the hour right there. So with that, let me show you my contact information if you have any further questions. Um, by the way, someone said they have a Wisconsin mailbox. It's the Tin Man from Oz. Send me a picture. I'll add it in the pile. I've got quite a few fun mailboxes. But be safe out there. If you have any questions, please send me an email or go to our website, nysltap.org. And with that, have a great 4th of July. And if you're Canadian, have a great Dominion Day next week. That's also my brother's birthday. And we'll see you in a couple of weeks for one of our foundational webinars. Take care, everybody. Bye-bye.